In this video, we will discuss the problem that is largest subarray of zeros and ones. The problem says that we'll be given an array of zeros and ones and we need to find and return the length of the longest subarray which is having equal number of zeros and ones here. So if you will see the very first test case which is having the elements 1 0 triple one and double zero. So in this particular array, if we start from the second element and take all the elements till the end, so this sub array that I have highlighted, it is having equal number of zeros and ones, and this and the length here is 6. So we have to return the length as 6. We have to consider like this for all the test cases, and we have to return the length of the longest sub array which is having equal number of zeros and ones. So how can we solve this particular problem here? Let's have a look at the test case by doing a dry run. Now, if you see this test case, how can we identify that a subarray is having equal number of zeros and ones? Consider a subarray like 1. Now, after that we have 0, then we have 1, and then we have got 0. Now, if there is a subarray like this, how can we consider that this subarray is having equal number of zeros and ones here? So basically, whenever I see the element 1, I'll consider the element as 1 only, but whenever I see the element 0, I'll consider that as minus 1. So what will happen is, in that case, let us say that if my array looks something like this here. Let's say if my array was 1, 1, and then 0, and then 0. So what will happen is, initially my sum will be 1, then my cumulative sum will be 2 next time. Then since I'm considering 0 as minus 1, so the sum will be 1. Okay. Now there's an advantage here. You can see if the same sum repeats, so this means that internal subarray is having 0 sum, which means that the subarray is having equal number of zeros and ones, because if the same sum repeats, uh, if I had already seen the sum 1 and it is repeating again, so this means that the internal subarray is having the sum equal to 0, which means that there are equal number of zeros and ones, since I'm considering the element 0 as minus 1. Now after that, if you will observe here, next time what will happen here is my sum will be basically equal to 0 here, and if my cumulative sum itself became equal to 0 also, then you can consider that my subarray from starting till this point is having 0 sum. Okay, so the main idea that I'm floating here is that whenever I see the element 1, I'll consider it as 1, but whenever I see the element 0, then I'll consider it as minus 1 here. Okay, and the basic brute force approach can be that I can try to explore all the subarrays in this given array, and whichever subarray has got the sum as 0, then I can say that that particular subarray can be considered if its length is greater than the result so far. So what we can do is, initially we can consider the subarray starting from here, then we can consider this subarray, then we can consider this subarray, this subarray, this subarray, then this subarray, and then this subarray. How can we do it? So basically one starting pointer can be here, and my end pointer can keep on moving as I keep on proceeding further here. Okay, so how will this work? Let's try and understand this. Initially my resultant variable will be declared as nothing but 0 here. Now after this, if you will observe here, what will happen is, initially my starting pointer is standing here, and my sum is equal to what? My sum is equal to 1 at this point. Okay, then after this what will happen is, my ending is also standing here, so we have considered this subarray, then my end will proceed further. Now since I am at element 0, I'll consider this as minus 1. So now the sum will become 0. Since the sum becomes 0, so I'll consider the length as ending point minus starting point plus 1. So it will be 1 minus 0 plus 1. So the length will be basically 2 here. So I'll update the result as what? As 2 here. Okay. Then my ending point will proceed further. It will be here. And my sum will be equal to what? Sum will be equal to now 1. Okay. So it's not equal to 0. Then after this, my end point will proceed further. And this subarray is considered sum of this subarray is 2. Then my end point will proceed further and the sum will become 3. It's still not 0. Then my point will proceed further. Sum will become 2 now, because I'll consider the 0 element as minus 1. Then my end point will proceed further and my sum will be 1. And you can see that I have not found any subarray other than the starting subarray, which was having 0 sum. Okay, now since I have exhausted all the elements here, so what will happen is my start point will move further, and now what is going to happen is my start pointer is going to stand here and my end pointer is going to be here. Now what will happen is, basically we will consider this particular element. Now initially this element is 0, so the sum will be minus 1. Then my end pointer will move further, now will be at this element, so the sum will become 0 here. Now after this, my end pointer will move further and my sum will be 1 here. sorry, since my sum became 0, so I can consider this length. But as of now, if you will see this particular length here, so the length is 2 only, so the answer will not get updated. Then after this, what will happen is my end pointer will proceed further, and at this point, my sum will be what? My sum will be basically equal to nothing but 1 here. Now, after this, my end pointer will proceed further. The sum will be 2 now. My end pointer will proceed further, and my sum will be 1 now, because at 0, I'll consider minus 1. Then my end pointer will proceed further, and my sum will become equal to 0. Now, since my sum becomes equal to 0 at this point as well, so I'll consider the length. So if you see the indexing 0, 1, 2, 3, 4, 5, 6. So the length of the subarray will be what? The length of the subarray will be ending minus starting plus 1. That is 6 minus 1 plus 1. So this is going to be basically 6. So the result will be updated to nothing but 6 here. Okay. Now, this is the maximum answer. We will keep on moving our start pointer further and we'll explore all the other subarrays, but I'm not going to do that much dry run. I hope you have understood the basic dry run here. Now, how will the code look like? You can see here that initially my result will be updated to what? To 0. Then after this, my starting pointer will be at 0. It will start from the beginning, and we'll consider all the subarrays from S till E pointer. Okay, initially my sum of this subarray will be equal to 0. So my end pointer will start from S and it will iterate till the end. If I see an element 0, then I'll add minus 1 in the sum. Otherwise, if the element is 1, so I'll add 1 inside the sum. And after this, what happens is if my sum becomes equal to 0, then that subarray is having equal number of zeros and 1. So the length will be E minus S plus 1, and the result will be returned at the end. The maximum length that I have seen, it will be returned at the end. Since I'm using two nested loop, one inside the other, so the time complexity of my code will be order of n square here, because I'm using nested loops. The space complexity will be basically order of 1, because I'm not using any extra spaces here. Now, how can we solve this more optimally? We can solve this more optimally using the prefix sum and the hash map concept that I had given you a hint about in the starting. Let's try and identify this again. So if you will see here, what we can do is we can keep on taking the prefix sum, and let us say that initially what will happen? Initially, my like let's update the indexes also. This is index 0, 1, then 2, 3, 4, 5, 6. Okay. Now what will happen here is initially when I'll iterate, so my sum is 1 here. Now with respect to the sum as 1, I'll update the index as 0. Now after this, next time I'm at this element, so what will be the sum here? Now since I'm at 0, so the sum will be added with minus 1, so the sum will become 0 overall. Now if the sum from the starting till the ith index becomes equal to 0 itself, so this means that the subarray from the starting till the ith index is having the uh, subarray sum as 0. So I should do what? I should consider the length as I plus 1. So if the index is 1, so the length of the subarray will be 2 here. So the result will be directly updated to nothing but 2 at this point. Now after this, when I'm at the next element, the sum will become 1. Now since I'm at the element, since I'm having the sum as 1, and you can see that 1 is repeating. I had already seen the sum as 1. So this means that in between the internal subarray is having the sum as 0. This basically indicates that the subarray, if it is having the sum as 0, internal subarray is having the sum as 0, because the sum repeats again. So this means that the internal subarray is having equal number of zeros and ones as well. Okay. So I'll consider the length here. The length will be what? The ith index, that is the index 2 minus the index at which this element 1 was found. So element 1 or sum 1 was found at the index 0 initially. So 2 minus 0 will be 2. So the length of this subarray is 2 only. So we'll not update the result. Okay. So also one more thing, by this time the sum 0 would have been updated with the index as 1 as well. Now after this, what will happen is, now when we are going away from this particular element, so should we update the sum 1 with respect to the index as 2? Should I update MP of 1 as 2? Should I do this? No, because if I see the sum as 1 again later on, suppose, then I want to consider the longest length. So I want to consider this one with this one. So that is why I'll store the very first occurrence of that prefix sum. I'll not update the indexes again. If that sum is not present inside the map, then I'll update with the very first occurrence only. Okay, because later on if I see 1 again, so I have to consider this much subarray length. Okay, now what will happen here is, next time I'll be at which element? Next time I'll be at this particular element 1. Now the sum will be 2. So what will happen inside the map? We'll update the sum as, like we'll update 2 with respect to the index as 3. Then after this, what will happen is we will get this element 1 again. So the sum will be 3. So in the map, we'll update 3 with respect to the index as nothing but 4. Then after this, what will happen next is we'll be at this element 0. So now the sum will be 2. Since it repeats. So the current index is 5 and the index at which the sum 2 is present is 3. So 5 minus 3 is 2. This particular subarray is having equal number of zeros and ones because this particular subarray is having zero sum. That is why the same sum repeats. So is this length greater than the result? No. So I'll not update. Then we'll proceed further here. And after this, next time my sum will be what? Next time my sum will be equal to 1 here. The moment my sum is equal to 1, then what will happen? Since my sum is equal to 1 at this point, then I'll check, is it present in the map already? Yes, it is present. And I've stored this particular index here. So this means that this internal subarray that I'm highlighting, it is having zero sum. So if a subarray is having zero sum, in our case, it indicates that it is having equal number of zeros and ones. So that is why I should consider this length. So the index currently is 6. 6 minus the index in the map with respect to 1 is 0. 6 minus 0 will give me what? It will give me 6. So the resultant length will be updated to 6. That 6 is the length of the longest subarray, which is having equal number of zeros and ones in this particular given array. Okay, now let us have a look at the code also. So you can see here how we are using prefix sum as well as the hash map approach to solve this problem. Initially, I'll declare a map here. Then I'll declare the prefix sum as 0. My result will be also 0. Then we'll start iterating for the elements. If we see 0, then we'll add minus 1 in the sum. Otherwise, if the element is 1, then we'll add 1. If the prefix sum till a particular index I becomes equal to 0 itself, so this indicates that the subarray from the starting till the ith index is having zeros, is having equal number of zeros and ones. In that case, the length will be I plus 1 because the subarray from 0 till the index I will have the length as I plus 1 here. Okay. Otherwise, what we will check is that if the prefix sum is already present in the map, then the length will be the current index I minus the very first occurrence of the prefix sum. So we'll get this length. If this length is greater than the result will get updated. If we are looking at this prefix sum and we find that it is coming for the first time, then we'll update it with respect to the index that we have found it at. At the end, we'll return the longest length, that is the result. Now, what is the time complexity here? The time complexity will be basically order of n because we are going to linearly iterate throughout the array. The space complexity is going to be order of n as well because I'm going to use a hash map so that in constant time I can access the sum and the indexing with respect to that sum. Now let's submit the code and check if it is getting accepted or not. So we have written the code. Let's try and submit this. So you can see that my code was able to pass all the test cases. I hope you have understood this clearly. Thank you for watching this video.